All right, in Unit 7, we're going to start off in Unit 7 looking at exponential functions. We're going to look at growth and decay functions. And growth will be anytime your value is getting larger, and decay will be anytime your value is getting smaller. But that happens in both cases, what we call exponentially. And an exponential function is in this format here, where y is going to equal some initial value. A is going to be a constant value. It's going to be how much you're starting off with. Now, if it's money, it could be dollars, it could be people, could be deer, could be amount of a chemical, could be lots of different things. It's how much of whatever it is that you're starting off with. And then B is your base, and that's your multiplier. It's what you're going to multiply by again and again and again. So maybe if we're starting off with $10, okay, maybe we're starting off with $10, and maybe we're going to double that. So we're going to multiply it by 2, okay? We're going to multiply it by 2 3 times. That means you're going to start off with 10, and then that's going to get multiplied by 2, which is going to get you 20, but then that's going to get multiplied by another 2, which is going to turn into 40, but then that's going to get multiplied, by 2 again, which is going to get you 80, because here's 1, 2, 3. That was the third power. So we start off with 10, and it doubles once, twice, 3 times. So this is the growth, okay? So this would be like 10 times 2 to the x power. In this case, x was 3. Okay, so this is an exponential function. It's going to, you have an initial value that's multiplied by some value x numbers of times. Okay, so in order for the initial value to get larger, your base or your multiplier here needs to be greater than 1. If you multiply by 1, it's going to stay the same all the time. If you multiply by a number bigger than 1, then obviously if you multiply 10 by a number bigger than 1, it's going to be larger than 10, because 10 times 1 would be 10, but anything larger than 1 would get you something larger than 10. If we wanted to get smaller, then we would need to multiply by a number between 0 and 1, like a half or a third or whatnot. Okay? So in this case, if we wanted to make it smaller, if we took 10 and multiplied it by a half 2 times, then this would be 10 times a half, which would get you 5, and then you took half again, then it would get you 2.5. So you can see the 2.5 ends up being smaller than the 10. Okay? So let's look at what the graph of this would look like. So here, if we had this scenario here, let's actually write it like this. Here's x, here's y, and here is 4 times 2 to the x. So let's start off, let's say x was 2. So this would be 4 times 2 squared. So 4 times 2 squared would be 4 times 4, which would be 16. Okay. If we had this being 1, because 16 is already large, so let's get smaller. If x was 1, this would be 4 times 2 to the first. Well, 2 to the first would be 2 times 4, which would be 8. Okay. Then if we made this a 0, this would be 4 times 2 to the 0. Any number to the 0 power gets you 1, so 1 times 4 gets you 4. If we let this be x be negative 1, this would be 4 times 2 to the negative 1. Now, 2 to the negative 1 is a half. Half of 4, that would get you 2. And if we went to negative 2, you can kind of see what's happening here with your y values. We go from 16 to 8 to 4 to 2. So looks like we take half of 16 to get 8, half of 8 to get 4, half of 4 to get 2. So that means this must turn into 1, because 2 to the negative second power is 1/4. 1/4 of 4 gets you 1. Okay. And then if this is negative 3, This would be 4 times 2 to the negative third power, so that's going to turn into a half. Okay. So if we plot some points here, at -3 we're at a half, at -2 we're at 1, -1 we're at 2, at 0 we're at 4, at 1 we're at 8, at 2 we're all the way up at 16, which is way the heck up there somewhere. So you can see what happens here is this starts off slowly and then skyrockets on you. But over on this side, this is going to get closer and closer and closer to 0, but it's never going to get there because this you're going to keep taking half of this. So this is going to go from a half to a fourth to an eighth to a 16th. It's going to get closer and closer and closer to 0, but you're never going to get to 0. Okay? So that's an exponential function. Starts off slowly and then all of a sudden takes off on you. Okay?